Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, I am going to discussing about the kidney disease predictions using Python and machine learning. This is an advanced type of machine learning project. Let's see the today's agenda. What are you going to covering on this project? First, we are going to discussing about the EDA, also called the exploratory data analysis. Then we have the data pre-processing technique. Then having the data clinic like handling the missing value, handling the categorical variable, all of the things. Then you have the feature encoding. Then you have the various machine learning algorithm. We're going to apply various machine learning algorithm and try to predict the kidney disease. Then we have the hyperparameter tuning. So there are various types of machine learning algorithm available like decision tree or XGBoost having the hyperparameter. So we're going to choose in the best parameter from the hyperparameter and try to do the tuning part. Then we have the model comparisons. So from all of the model, we're going to choose the best model and try to save it inside the pickle format. So बिना किसी डर के हर हर महादेव बोल के start करते हैं tutorial. In order to building the kidney disease predictions, we're going to using a dataset from the Kaggle that's called the chronic kidney disease dataset, and it having the 26 column. Now using this dataset, we're going to building one machine learning model and try to predict the kidney disease. After downloading the dataset from the Kaggle, I have one CSV file that's called the kidney underscore disease.csv. Now using this CSV file, I am trying to building one machine learning model and try to predict the kidney disease. So for this project, I'm going to using here the Jupyter notebook. You can also using here the VS Code, Python, or Google Colab itself. And this is my IPYM file in my same working directory. So I'm simply going to go on here, and this is my IPYM file. So first thing first, I'm going to importing here all the necessary library and try to import the dataset from my directory. So first, I'm going to import here the pandas as PD, and using pandas, you can also load the dataset from your directory. Otherwise, you can also do the data visualizations. Then we having the NumPy for numerical computations. If you have the some numerical types of tasks, you can also do it using that. Okay. Now I'm going to import here the matplotlib. So matplotlib is nothing but one visualization library in Python. So pyplot as plt. Okay, this is one visualization library. Using that, you can do some visualizations. And after that, I'm going to import here the Seaborn. So which one is also an extreme level of data visualization library. Is working top on the matplotlib. Okay, it's called the Seaborn. Then we have another visualization library that's called Plotly, Plotly, Plotly.express. Let's say as px. Okay, that's it. Now I'm going to import here also warning, because in some cases when you try to do the plotting, it maybe give you some kind of warning. So that's why I'm trying to make it warnings.filter, warnings.filter warnings. You can also using here the tab keyboard from the keyboard and to give you the auto suggestions. Now inside this filter warning, you need to give here the actions, which kind of action that you're going to take. So I'm just going to ignore all the warnings that actually happening inside my code, right? Then I'm going to import here. I'm not going to import it here, just I'm going to give here some status style, because if I try to using the matplotlib, it will give me some odd kinds of plot which one is not good. क्योंकि हम अब डिजिटल जमाने के बच्चे हैं, so we need some digital types of plot, right? Extra होना चाहिए, right? खूबसूरत होना चाहिए. So that's why we need to using here some style. So let's say plt dot style. थोड़ा style use करते हैं. Okay, not a style dot use. So I'm going to using here the ggplot. So it will give you some different kind of digital types of plotting plot, the graph or bar chart like that. Then what I'm going to do, I'm simply going to using here first sns.set. Then I can give here the style. So let's first using here the sns.set. Then I can give here the plt.style.use ggplot. Okay. Otherwise, I can also using here another one that's called plt.style style.use. Let's use this also one. It's also good. It's called a 538. It's another types of style in the plt. 530 thirty 30 38 like that. Okay. Okay, our style is sad. Now what I'm gonna do, I'm simply going to give here the matplotlib inline, so that I don't need to using here the plt.show. If you don't give me the plt.show, it will give you the exact bar without using the plt.show. So that's why I'm going to using here the matplotlib inline, so that it can show me inside my Jupyter notebook. That's using in the shift enter. Okay, so it will importing all the library in my kernel. Now what I can do, I'm simply going to load the dataset from a directory. Okay, so you have to load the dataset. You're going to using here the pandas. So that's a pd.read.csv, pd.read underscore csv. Okay, then I'm going to using here my dataset part. So it's in my same working directory. So kidney disease dot CSV. Okay, fine. Now let's sign into the variable that's called the df. Okay, fine, it's loaded. Now let's checking for the head. Okay, this is the head of my data set. It having the 26 column and having the 5 rows, not 5 rows, just initial one. When using here the head, if I give here the 10, so then we have a 10 row, right? Like that one. So it having the 26 column. Now I need to identify that is it a classification problem or a regression type of machine learning problem. So if I go here, I can see in the last one, it having n column that's called the classifications. So let's checking for the value of the classifications. Okay, so that we can say that is it a classification problem or a regression type of problem. I see it said nothing but a classification problem. It already told me that it's a classification problem. I don't have the value, right? It's just having some text. So obviously it maybe should be the classification problem. Now the question is it a binary classification problem or a multi-class classification problem? So what I can do, I simply going to using here the df, and inside that I'm going to using here these classifications. कंट्रोल सी करना है, कंट्रोल बी नहीं. Okay, इसका बाद क्लासिफिकेशन पेस्ट कर दिया. Okay, then I'm going to using here the value counts dot value counts. So it will give me the giving here the all the counts. So it having the CKD, not CKD, and also CKD. Maybe this is the problem. Maybe some types of outlier or not. Some types of error actually happening. You can also import it. We can also replace this out with the CKD. That's mean this having just two classes, and this is one supervised machine learning problem and also one classification type of machine learning problem. Right? So now let's checking the shape of the data, that how many row and how many column are available. Okay, df shape is not a list. Okay, it having the 400 row and 26 column. Now using this 400 row, I am trying to building one machine learning model. Okay, तो यहाँ पर देखो id is not necessary, so we can simply drop it out. So let's try to drop it out. Let's say df dot drop. So देखो कैसे drop करते हैं इसको. So let's say I'm going to using here my id, then I'm going to using here my axis equal to 1, then I'm going to making the in place equal to true. Simple. Using this one, you can actually drop your column from your data set. If I try to check it out, let's say df.head now, and you can see here without id it having the data set. Now you can see here h and bp means the full form of the bp is nothing but called the blood pressure. Then sg is also called the specific gravity, and al it's also called the albumin, and fu it's mean the sugar. So it's just in the short form. So what I'm going to do, I'm simply going to for the just for the user friendly, I'm trying to actually make this pp to the blood pressure. A specific g is to be the specific gravity. So I am simply going to type it here. I'm just going to pause the video because it will take time, right? Well, so I'm simply going to rename all the column. That's called the H. H is okay. BP means blood pressures and all of the things. And that's simply going to type it here and try to rename it. Okay. Now using Shift Enter. And now if you try to checking the df.head now. So let's say head. And now you can see here BP is converted into blood pressures and a specific gravity, the albumin, the sugar, red blood cell, the push blood cell, push cells, clumps like that. Okay, all of the things I'm simply going to actually convert them for the just for the user friendly, so that you can understand what the means actually BP means and what the meaning of the SC. So that's why I'm simply going to rename it. Okay, just for the user friendly. So now let's try to checking for the density. Let's say df.describe. Okay, describe. You can also tell the description of the data set. So describe. So it having the count. I mean, how many count are available? Then it having the mean, the standard deviations, the minimum, the 25% percentile, 75% percentile. Okay, and all of the things we have, right? So count the mean, standard deviations, the minimum, the 25% percentile, 50% percentile, 75% maximum. So which one is really important when you're trying to detect the outlier in your data set? Okay, so I think data set is quite okay. And if I checking for the maximum and the mean value, so it's not have the much more amount of different. That's mean you don't have the outlier in our data set. Not so quite outlier inside our data set. Our data set is okay, fine. So we don't need to deal about the outlier in this data set. So now let's checking for the information regarding my data. Let's call data.info. So like that, and it give me the information regarding my data set. If I checking this data set inside the data set, it having the 11 columns are nothing but the 14 file number, and objects having the 14 column are nothing but the objects. Okay, so now if I check these things again, see age is floating, that's fine. And also if I checking uh, this object red blood cell, push blood cell, then you're having the push blood cell, iska baad hai objects, all of the objects. But rest of the you can see packed cell volume is nothing but one, it may be the integer, the floating point number, right? But it actually assumes that it's nothing but one object. And same things you can see white blood cell count is nothing but one object, but this is nothing but a floating point number, right? Floating point number, and you can see the red blood cell count. So count should be always be the floating point number, but it's shown that it's just like a objects. It's just like a object. So what I can do, we can simply going to convert this object column to the numerical column, right? Because you simply see that this is nothing but one numerical types of balloons, but it just show the data frame, I mean data types as a objects, data type as a object. So what I can do is simply going to convert that inside into a numerical types of value. So for that, I'm simply going to using here this packed cell volume, the white blood cell count, and the red blood cell count into the object to the numerical value. So for that, I'm going to using here like that. So let's take some shell. That's the df, and I'm going to giving here the packed packed cell volume to the numerical value. So for that, I'm going to using the pandas. So pd dot to numeric. You can also using here the tab key from your keyboard. Then we have the this one. So let's say I'm going to copy this one. Copy this one. I'm going to simply paste it here. Okay. And after that, let's give here the if there are any errors. So I can just simply going to make it COERCE. Okay. COERCE. Okay, that's fine now. It's now converted into the numerical one. So I'm simply going to copy this out, paste it here. Okay. And I'm simply going to copy this out from here, white blood cell count, and I'm simply going to convert them like that. Okay. इसको भी करना है, कर दिया. That's all fine now. Now if I try the checking for the information in info, let's say info. Now you can see it will convert this data set into the where is it? Yep, you can see here now floating 64, float 64, right? Now it having a floating point number 14 and objects are 11. Okay, now we have our data set. Now what I can do is simply going to cleaning our data set and try to start in the numerical columns and also the categorical columns. Okay, I think I need to restart my PC. Then I will back again. Okay. Well, so I'll back again after restarting my PC. So what to do earlier, we just converting our object column into the numerical column because volume and the count is cannot be in an object type. So that's why you just need to go into convert them into the integer even though in a floating point number. So that's why simply going to convert them into the numeric using the pd.to numeric functions and try to pass the packed cell volume and the white blood cell count and the red blood cell count and try to convert them into floating point number, right? So now it's converted into float 64. So now you can see we have in the 14 numbers of float 64 and 11 number are objects. So we're simply going to starting all of the floating point number, or you can say numerical types of number and categorical types of number. So in order to starting that, I'm just simply going to creating here one list comprehensions. Let's say if df of column dot d type. D type mean data type. Okay, d type is equal to object. Okay, that's mean this is one categorical features. So now I need to also initialize here the columns. So which column is it? So it is coming from my df dot column. Okay, it's coming from df dot column. If I try to checking this out like this way, that's a df dot columns. Okay, so it having all of the columns. So now it's nothing but inside one list. So simply what I can do is simply going to iterate to all the value from here. So let's call in df dot columns like this way. Okay, now I need to also initialize these columns in my list comprehensions. Now I have the value of my columns. Well, now let us assign to the variable. Let's call the cat columns. Okay, also call the categorical columns. So it's underscore. Okay, now let's copy this out and also try to paste it here. Now this is nothing by my numerical column. Let's say numerical column, and that's okay, fine. Column d type is not equal to objects because numerical can be the floating point number, even though the integer numbers there should be that's nothing but should be one numerical value. Okay, but in my cases it having just a float 64, so that's why simply using here, if it is object then take it as a categorical format, if it is not an object so take it as a numerical format. Okay, fine. So shift enter. So now if I try to checking for this cat columns, it will give me all of the categorical column. Okay, all of the categorical column. And if I'm checking for the numerical column, so I can say numerical columns like this way. Okay, all of the numerical columns. Now I'm going to checking for the unique value inside all of the category columns and also the numerical columns. Better you can checking for the category column, because in the numerical column it cannot be any unique types of value because there are a large number of values. Okay, but in categorical variables, in I see there is a problem inside my data set. If I check this out, you can see here CKD slash tab. So this is inconvenient, right? So I need to also handling this out. So for that, I need to also checking for all of the columns, all of the category columns. So for that, I'm simply going to creating here one loop. So let's take some shell also. थोड़ा ले लेते हैं यहाँ पर. Okay, हो गया. Okay, now what I'm gonna do, I'm simply going to creating here one loop. That's a column in categorical columns. So cols, and I'm simply going to printing it here. So let's try to printing the column and also the printing the unique value of each of the columns. So that's why I'm simply going to creating here an f string. It will be better for me. So let's creating here f, and inside that I'm going to simply passing here my columns and also my unique columns. So that's why I'm going to simply pass here df of all of the columns dot unique. Okay, unique, simple. Now let's assign to like this way. Let's say has. Okay, so now you can see here red blood cell has nan, normal and the abnormal. Okay, push cell has the normal, abnormal and the nan. Yes, nan value can be happening, you need to just handling it out. It's nothing but a missing value, it's not a problem. Push cell also don't have anything else, bacteria don't have anything else, hypertension no, diabetes mellitus has yes, no, nan. Okay, fine. Then coronary artery disease has no yes, nan. Okay, I think I need to run it again here because run all. Just from the beginning. थोड़ा सा यहाँ पर प्रॉब्लम हुआ है शायद. up आ गया. Okay, up आ गया. Yes, now you can see here it don't have anything else. Now you can see here it having the slash t no and slash tes and slash t no and also the ckdt. Okay, now you can see here it having all of the unique columns. I think I restored them PC, that's why it's happening maybe. Okay, now you can see it have a slash t no and slash t no and slash t yes. So now what I need to do, I simply need to actually convert them into the two no, sorry, no, and this one to be the yes and this one to be the no also. Okay, and also you can see here ckd slash t, and it also convert them into ckd. Ckd means chronic kidney disease like that. So we can simply going to replace them, is simply going to replace them. Here I don't need to replace it because nan can be happening inside the data set. We can simply handle in that. That's called a missing value. Simple. Okay. So now I'm simply going to converting this diabetes from the diabetes mellitus, then coronary artery disease, and also the class, right? It having. So that's a df of this one diabetes, this one mellitus, and I'm simply going to pass it here. I'm simply going to replace the value from this column. So let's say replace, and I have to give here two replace functions, two replace, okay, attributes. So inside that, what I'm going to do, I'm simply going to creating here on dictionary. So inside this dictionary, I having my key and the value. So my key is backslash t no. If it is get it, I'm simply going to convert them into the no, and again if I have the backslash of tes, like the tes, I'm simply going to convert them into the es, right, into the es. Okay, let's take that yes, fine. So now I need to also giving here in place equal to true, so that we don't need to store it again inside the same variable. If you don't give here the in place equal to true, you need to also actually replace it inside the same variable name. So you can also using here in place equal to true, so it will in place these things inside your whole data set. So now I'm going to do it for my coronary artery diseases. It having just one, you can see here just t no, one single. So let's try to do it in another way. So let's say coronary artery disease like this way. If it is having one value, single one value, I can simply using this like this way. Let's say replace, and I'm going to using here to replace. Okay, to replace equal to just one single column, right? One single column. So what I can do, I simply going to do it like that. T and no, and I need to give in here the value. That's a value equal to no. Okay, you can also do it like this way. This way. Now in this cases, what you need to do, you need to simply pass it inside the same variable. Okay, pass it inside the same variable because it don't have the implicit equal to true right now. Okay, now we're having the another one. Let's go to class. So let's try to do it here. So what I'm gonna do, I'm simply going to convert the ckd slash t to the ckd and not ckd, just giving here a simple space so that it looks good. Okay, so let's say class, and I'm simply going to using here like this. Let's say df of class. Okay, just going to show it here without using the implicit equal to true, right? Dot replace, and I'm going to using here to replace. Okay, to replace equal to ckd, which one, ckd slash t to ckd, and I'm simply going to making this non ckd2 not ckd, not ckd, like this way. So now you don't need to actually giving here the in place equal to true because I just pass it in the same variable, so that's why simply shift enter. Okay, it's now converted the data set into the this types of web. So now what I'm gonna do, I am simply going to checking this one. Okay, unit value of the df bot militas. Let's try to check this out. Otherwise you can creating here on simple list. Okay, let's try to do it. Let's say columns equal to all of the values. Let's say copy this out, and simply going to iterate to all the value, unique value from here. Here is it. Okay, you have to paste करना है. Then you have in the class. Let's say class. Okay, so simply I'm going to creating here one loops. Let's call in columns. So I can simply copy this from here. Okay, just copy this from here, and now I'm simply going to paste it here. Okay, that's fine. Now you can see here all of the three columns. Yes, no, but it having also one yes. Oh, see, in the same yes, it having one simple space. I need to also replace them क्योंकि ये human mistake है, human error है who actually made this data set. Yes, this kind of error you can get when you try to work in a real world company. So there are so many noisy kind of data. You just need to clean up the data. That's why I chosen this one. Kidney disease predictions. So let's try to do it out also. So let's try to do it. Just space yes and need to replace it with a yes. Simple like that. Okay, thoda ho gaya. Now you can see here our data is clean. Yes, no, no, yes, and ckd not ckd. Fine. Now what I can do is simply going to convert the ckd to the 0 and not ckd to the 1 because this is nothing but my target column. Okay, this is my target class. So that's why I'm simply going to convert them to the numerical one, right? So for that, what I can do is simply going to creating here on map. So let's say class in the same variable. I'm just going to replace it. So let's say class. Okay, and I'm simply going to make it replace either pe. Okay, let's try to using the map, and I'm simply going to using here. If it is ckd, let's try to make it 0. If it is ckd, let's try to make it 0. If it is not ckd, I am simply going to make it 1. Okay, now I am simply going to replace it with the numerical value. So for that, I'm going to using here pd.toNumeric. So class equal to pd.toNumeric that we do earlier, same thing here. And now I'm going to convert them into the numerical one because you know how I try to do that, you know, to also convert them into numerical one. Otherwise, it's maybe the happening it converted to the object type that you see earlier in some three of the classes. So let's say class, and I'm simply going to convert them, and also need to give in here the errors. So errors is always be uh, COERCE. Okay, now it's converted them. If I try to use this again and try to shift here, enter, and you can see here it having 0 and 1. Well, that's really fine. Now what I can do, let's checking for the distribution of the features, numerical features column. So you can also do the distribute the numerical feature column. We already extract the numerical column also. Okay, so let's try to creating here one figure just for checking for the distributions. So let's say I'm going to using here pld.figure, and I'm going to passing here the my fixed size. fixed size equal to 20 comma 15, and I'm simply going to giving here uh, one loops. That's 4 columns, column in numbers of column that you already extracted. Okay, and now what we can do, if there should be maybe 14 columns, 14 numerical columns, hope so. If I see, yep, 14 numerical columns, so you can simply creating here on if conditions. Let's say float number, and I'm simply going to make it, let's say if it is greater than 14, then simply I'm going to creating here one subplot of axis. So let's say plt dot subplot, and I'm simply going to creating here 3 comma 5, because it having the 14. Okay, 14 means in the each column it having in the each column it having the uh, five figures. In the last one it don't just having the fourth. Okay, so I'm going to give him the float number. I mean कितना float में वो होना चाहिए सब plot इसका, but I'm going to using here the sns dot displot for checking the distribution. I mean the feature distributions. So that's why I'm just going to using here the sns dot displot, and I'm going to passing here my columns. Okay, columns. Okay, column or columns, column. Okay, now I'm going to using here the plt dot x level, and I'm going to passing here my column. Okay, column, and what I can do, I'm simply going to increment it, float number, increment it plus equal to 1. So I need to also initialize it before, otherwise it will give me the errors that variable not found. Float number equal to, let's say start from 1. Okay, fine. Now what I can do, I'm simply going to using here the plt dot tight layout, so that थोड़ा tight में layout हो जाए. So let's try to using the plt dot show now. Okay, so it will show me the nothing but the feature distribution of each of the columns. So you can see, okay, maybe some errors maybe. Okay, just having some problem in my maybe the Jupyter notebook. Now you can see it actually run it correctly. You can see all the distributions of the features, distribution of the numerical columns. It having the 14 one, if I see that just accept the one columns, okay, it will try to show it in a 5 columns. You can see 5 columns and the 3 rows, 1 2 3 4 5, and it having the 3 rows. So that's why I decided here subplot is 3 comma 5, and try to give it a float number. In the which float number you try to printing it, right? So it having the age, the blood pressures, the specific gravity, the albumin, the sugars, all are the nothing but my numerical types of columns. And I see that the data series looks good. Okay, it looks good. It don't have any outliers in my data set, so I don't need to actually handle it out, even though I have the 400 features. So now what I can do, I am simply going to also looking for the categorical columns also. So I'm simply going to copy this out. Okay, and I'm going to using here the distribution of the same. I can do the displot. I can simply go into using the count plot here. So for that I'm going to using here this categorical columns. Let's get calls like that, and I'm going to using here the count plot, because in the categorical column you cannot go using the displot. So that's why. So let's try to using here the columns, and I'm going to giving here on palette. So let's say palette, palette. Okay, a palette, and I'm simply going to giving here palette. Let's say giving the rocket palette. Guardian of the Galaxy का rocket है. अच्छा, किधर C1 has no attributes called count. Is count plot. Okay, count plot. Count plot. Okay, now you can see the count of the each category columns. You can see red blood cell column, normal and abnormal. I see that it having just 2 features. Normal ज़्यादा है यहाँ पर. Then you can see abnormal, the present ज़्यादा कम है. Bacteria not present. Okay, yes or no में no ज़्यादा है. If I see the classes, inside this classes, 0 means the CKD, I mean the chronic kidney disease. Most of the people having the chronic kidney disease. Less number of people, maybe 150. Okay, it just having the, it not having the chronic kidney disease, right? This is nothing but one simple count plot. So let's try to also use the correlation matrix. Let's try to df.core for checking the correlations. So this is mathematical correlation matrix. So I can also using it using the heat map. So I'm simply going to using here sns dot heat map, and I'm simply giving here df.core, and inside that I'm going to be giving here annotations. Let's make it true, and also let's say giving a line width, d2 width, line width, let's giving here 2, and also giving here one indicator line color, so let's say line color, so kya chahiye, light gray dete hain, light gray. Okay, so I'm going to using here one figure so that you can look see it in clearly, otherwise it may be quite big bhi ho jayega isliye. So let's say plt dot figure, and I'm going to passing here my fixed size, and after that I'm going to using here my 15,8. Okay, I just hit and trial and I make it out. So let's plt dot show now. Well, you can see here this is nothing but a correlation matrix. Okay, that's fine. Okay, that's my correlation matrix, and seems like it don't have any actually the outlier in my data set. Okay, but having some negative correlation also, and also have the positive correlation, so it having just last number of features. So we can also explore the data set. Okay, it's better. So let's try to do the exploratory data analysis, just EDA. Okay, थोड़ा और भी करना चाहिए, इसके बाद we can select some extra feature and try to do the feature encoding. Okay, now let's defining the functions to creating some plot. So first let's say defining on another plot called the Boolean plot, so that you can add it in your paper. So let's say Boolean plot, how can I creating the Boolean plot? So for that I'm going to using here px dot Boolean. It's available inside the Plotly Express Boolean. Okay, Boolean plot, and I'm going to passing here my df, and y equal to, I'm going to passing here all of the columns, and x equal to, let's say I'm going to giving here the class. Based on the class I need to simply going to creating here the Boolean plot, and let's giving here the colors, so same color class mein de do. Then I'm going to using here the box. So box kya ho, ye true hoga. Okay, box chahiye mujhe. So template kya chahiye, तो template hai Plotly mein. Template is nothing but call, let's say using here the Plotly Dirk, Plotly Plotly Dirk. Okay, and I'm going to using here the return the fig dot show. So fig इधर में जाना चाहिए, so fig equal to px dot Boolean plot. I'm going to using here px dot show. Okay, now let's define here another function, let's call kd. Okay, so kd में की चाहिए, column चाहिए, इसका बात है. So you can using here the fact grid inside your Seaborn library. So I can simply using here the sns dot the face. Okay, it's go, you can say face t grid, and I'm going to passing here my df, and inside the hue I'm simply going to passing here my class target columns, and let's giving here a height so that it looks better. So height kitna dena chahiye, let's make it 6 now, and expect, let's say giving here 2. Okay, I can simply going to using here my grid map, so I just need to initialize it inside the grid. So let's say grid grid equal to sns dot fact grid. So I'm simply going to using here the grid dot map, and inside the grid dot map I'm simply going to using here sns dot kd plot. Okay, so that it's like inside the grid it will just showing it up. So kd plot I'm simply going to using the columns, and after that I'm going to simply going to use add it inside my layout. Okay, layout. So add layout, aja. Okay, add legend. Okay, simple. Now I'm simply going to also printing here the scatter plot, the numerical columns. Okay, so let's try to using here df dot scatter plot, and I'm simply going to giving here the column 1, the column 2, because in the scatter column you just need to passing here 2 columns, and based on the 2 columns it will try to print some data pointed. So let's say using here the px dot scatter plot. So px dot scatter plot, and I'm going to using here my df, and inside this x I'm going to passing here my column 1, and inside the y I'm going to passing here my column number 2, and after that my colors I'm simply going to passing here my class, and after that I'm going to giving him a template. So template Plotly Dirk I can also give it out. Okay, quite good. Okay, Plotly template here. Now I'm going to using here the figure dot show. So now to assign it to the same variables, let's say figures, and after that I'm simply going to return it. Okay, so let's return the fig dot show like this one. Okay, fine. So that's it, our function is ready now, so we're simply going to call it out here. For that I'm going to, let's try to first do the kd. Okay, kd. So let's try to using here the red blood cell. So let's say red underscore blocked blot. Then I'm going to using a cell count because this is a numerical value. So cell count. Okay. This is the KD of my red blood cell count is based on my classes. I mean, how many classes are available. So I had the two classes. So this is not a distribution of the classes. The kernel density explanation. Okay. So that is look like that how it actually working in terms of your class level, how it is go up and how it is go down based on your features column. I mean the your class target. Okay, you can also do it all of the things. I mean all of the cases you can do like what blood cell count and all of the columns you can actually do it out. Okay, or all of the numerical column you can actually using here the KDE. Okay, so it's your task to do that. You can also using here the scatter plot. Okay, you can also do the scatter plot. You can do the Boolean plot, all of the things you can actually do it out. Okay, I just simply write it out. Your job is to actually test it out. This Boolean plot, the scalar plot. I'm not going to show it out, right? It's just nothing for when you can actually try to add it inside a receipt paper, even your final product. I'm simply going to creating here this kind of UI. Okay, so now let's try to do the data pre-processing. Okay, data pre-processing, processing processing. Okay, like this. Okay, data pre-processing. It's your task to do the exploratory data analysis. It's not necessary. Yes, it's some cases it's necessary. So I'm just not going to wasting the time here. So data pre-processing. So let's checking for the null values if there is any null value or not, and it's also handling it out if there is a missing value or not. So let's say df dot is null dot sum like this. Okay. So it having the all of the null value. I see there are so many null value are available inside my data set. So let's try to short it out. Let's say short value. So short value, and I'm going to passing let's say ascending order. Ascending में चाहिए or ascending type दो आता है नहीं आ रही है ascending. Let's making is false. Descending में चाहिए मुझे, ascending में नहीं चाहिए. Okay, let's try to make it out now. Series of that has to be a short values होगा शायद. Up आ गया. Now you can see red blood cell it having the most number of missing value. Okay, it's called checking for missing value. Checking for missing value. Okay, fine. So there are so many missing value are available inside the red blood cell. We see that we just having the 14 rows. I mean 14 numbers of value. But inside this 14 numbers value, you have the 152 missing value. That's quite inconvenient, and it also handling this out. So what I can do, I am simply going to also checking for all of the numerical columns, and after that I'm try to do it for the category columns because I need to handle also the category columns and also numerical columns. So it's better I can extract the numerical columns from here because how I try to impute it. Okay, I need to maybe using here some random sampling, maybe I need to using here some mode or medians. So that's why it's better I can actually just divide our data set in the numerical columns and the count of the missing values, so it will better. Okay, so that you can apply it in another kind of actually technique inside the category columns and also numerical columns. Okay, I think you hope sense too. So let's try to using here the numerical columns. Okay, numerical columns it having already. So let's say is null and dot sum. Okay, and those are nothing but my numerical columns. So I can do some random sampling, even though I can also place it using the mode or the medians. I can do it out. Okay, in the same, it's not the same way for the category of the numerical columns. So what I can do, I am simply also going to checking for the category columns. So let's try to copy this out, and there's lots of missing there, right? So let's say cat columns. Cat columns with cat नहीं है भाई, dog नहीं है, cat है, category columns है. So this is also one category columns. I think if I try to check it out, just to avoid df.head and df.head. So you can see in the red blood cell it having normal, it also having a nan value. It's just considered nan value as a missing value, and you can see a push cell. The push cell columns is nothing but the category columns, right? It's nothing but a category columns. It's also having the some missing value, and it also handling this out. Okay, so for that what I can do, we simply going to filling this null value. We actually using here two methods. We're simply using here two methods. That's why I divided this data set in numerical and also the categorical one. So what I'm gonna do, I simply going to using here the random sampling for higher null value. Okay, for higher null value, which are having the higher null value, like red blood cell. I see you can see red blood cell having the 152, this higher null values. We can simply using here the random sampling. Okay, and for the lower null values, I'm simply going to using here the mean or mode. Okay, mean or mode. Okay, mean or mode. So sampling for lower null value. Okay, I just simply going to creating here because there are so many null values available inside my data set, and our data set just having the 400 features column. Okay, features row. So that's why I just need to handling this thing in a such a way so that I can get here the best accuracy inside my data set, right? So that's why I select this data set. Is quite complex, I know. So now let's try to define here two functions. So let's say daf, it's called the random sampling. Okay, let's call random sampling. Okay, random sampling, and inside that I'm going to giving here my features. Okay, so features. So after that I'm going to creating here all of the features and try to drop all the null values. So let's say I'm going to using here the features, passing here features, and I'm trying to using here drop null value, all of the dropping the all of the null values, and inside that I'm going to passing here my samples, and inside the sample I'm going to passing here my features column. So let's say features, and now I'm going to use tagging that is null. Okay, it's now you can also like this way dot sum. Okay, and simply going to dropping all the features value, sample of the feature value, just sample all. Okay, and try to pass it inside my random sample. देखो कैसे करते हैं उसको. First we dropping all the features column, the sample of the features column, sample delete किया है. Okay, sample delete किया. Now inside the same random sample index, inside the same random sample index, I am trying to going to pass all the value. I am simply going to pass all the values. For that I'm going to using here. So let's say random sample dot index, and I'm simply going to passing here all of the values index number. So let's say df of features, features, and I am simply going to checking for is null, and I'm simply going to passing here the index number. That's it. Now I'm going to add it inside the same locations. Let's say df.log, and inside that I'm going to using here df of features. So df features and same index, and passing here my is null. That's it way. And I'm going to passing here my features, all of the features, which one is passing from here, and I'm simply going to using here the random sample. Okay, random sample function is creating. Now let's try to using here the impute one. I mean the impute mode and the median. So what I can do is simply going to using here, let's say daf, let's say impute first using here the mode. Let's start using here the mode. Okay, and I'm going to passing here my features column, the features, and after that I'm going to using here mode equal to df of all of the features, and I'm taking the mode of all of the features column and try to passing here the first index number because it will give me inside a list. Now I'm going to passing here all of the value inside my features. So features equal to df of features, and I'm simply going to passing here all the field null value with the mode. Simple. So our imputation is done. Now what I can do, I am simply going to filling the numbers of column, and I mean the numerical values is a random sampling method. Using this random sampling method. So let's say for columns in numerical columns, I'm simply going to using here the random sampling. Just going to using here the random sampling for numerical value. Okay, that's it. So let's say numbers of columns into columns. I'm simply using here the random sampling, and I'm going to passing here my columns. That's it. Now all the columns is converted into the numerical columns will be filling the missing value. So let's say if I checking this one, that's a numerical columns dot is null dot sum, and if I'm checking this out now, so you can see don't have any missing value. Okay, don't have any missing value. So you're handling this out. Now what I can do, I am simply going to also uh, using here the random sampling inside your red blood cell and the push blood cell, because it having the higher value. And you can see in the numerical column all of the values are higher missing values. That's why actually using here the random sampling. But in the category columns, except the two columns, it don't have any, it don't much have any the missing values. So that's why I decided that it's better I can just convert in this two, one is a random sampling, and except of them I can replace with the mode. So why mode actually? Because this is nothing but one categorical types of columns. That's why I have to import it with a mode. If it is numerical columns, I can simply import it using the mean. Okay. If it is having a layer number, last numbers of missing values. So now I'm going to using here the random sampling. So random sampling, uh, sampling, and I'm going to passing here my red blood cell count, red not count actually red blood cell, so red blood cell, and because it having the higher null value, so let's say random sampling, sampling, and I'm going to using here the push blood cell, push cell or push cell, okay, push cell like that. What a mistake what I have. Okay, now I'm going to iterate to all the value from here. Let's say call in categorical columns, let's say cat calls, and I'm simply going to pass it the input mode. So input mode, and I'm passing here all the columns. Okay, let's see, we got some error. Red blood cell, it's not having red. So let's see, red blood cell किधर red blood cells, not cell by mistake तो हो जाता है. Okay, so now if I try to checking for this one, let's say df of cat columns, so cat columns dot is null dot sum. Now you can see don't have any null value inside your categorical columns, right? So this is how you can actually handling all of the things. But you need to also do the feature encoding, right? You need to also do the feature encoding. If you try to checking this out, let's say it's called the feature encoding, because it's nothing but one category column, and it also convert them into numerical column so that I can pass it inside my machine learning algorithm, right? So for that, I'm going to using here, let's say for calls in cat calls, I just need to checking for all of the categories, that how many categories are available inside my category columns, that you already checked this out, right? So let's say let's try to print it out. Let's try to print, and let's creating here an f string, and I'm passing here the two curly brackets. So let's say it was nothing but my columns. So that's columns, and I'm going to using here the number of unique value. Let's say s, let's say df underscore, we're passing the columns. Let's try to using the number of unique. So let's say n unique. I mean कितना unique number है यहाँ पर. Okay, red blood cell have two, push cell has two also. It all of the values having nothing but two features column, I mean two features. Okay, so what I can do, we can simply creating here the level encoder, because it's just having the two categorical columns. You can simply using the level encoder. Otherwise you need to using here the map, you need to using here the map one. Okay, just need to convert them into 0 and 1, because this is the category column, right? But I see they're just having the two columns, so I can using here simple level encoder. Okay, you can also using the pd.get dummies, but when you try to using the pd.get dummies, it will give me some kind of extra column, so थोड़ा mistake हो जाएगा. मैप भी यूज नहीं करना क्योंकि यहाँ पर दो फीचर है. Okay, so you can using here the simple level encoder, and coder use करते हैं. So level encoder available inside the scikit-learn. Let's say sklearn dot preprocessing, and I am simply going to import here pre-processing. अरे भाई आजा, enter दे दिया. Import the label encoder, so L capital होगा, label encoder, yep, label encoder, and I'm simply creating here one instance of that. Let's say LE equal to label encoder, label encoders, and I'm going to using all of the categorical column and pass it inside my level encoder. So for that I'm simply using here the for loop. So let's say for column in categorical columns. Okay, categorical columns, थोड़ा raw code कर रहा हूँ मैं ना. So now I'm going to pass it inside all of the columns, and I'm simply going to transform it. Let's say le dot feed transform. Okay, feed transform, and inside that I'm going to passing here all of the columns inside my data set. So it's now converted our data set into the numerical walls of the value. Let's try to check this out. Now you can see here red blood cell or the columns is converted into 1 or 0. It's because it having just two features columns. So I just simply using the label encoders. So that's it about the data preprocessing, the features encoding, and also the EDA also. Okay. So now we're going to focusing on the model building. So that's a model building. building. Okay, model building. Okay, so now what I'm gonna do, we need to also we already convert our data set in numerical columns, and I need to also extract them into the dependent and independent features. So it having the X and also the Y. So what I can do is simply going to using here df.drop, and I'm simply going to drop the except the class column. I'm simply going to dropping all the column from here and assign it inside my same variable. I'm going to using here my class. Okay, just class. Okay, my df.class. Okay, I'm simply going to using it here. Okay, df.class, df class like this. So now I divide this data set into the dependent and independent features. If I'm checking for the X, this is my X. If I'm checking for the Y, this is my Y. Simple. Now I'm simply going to split our data set into the dependent and the independent features. Okay, dependent and independent features. So what I can do, I'm simply going to creating here the train test split. So for me, I need to also import it. Let's say sklearn dot model selections. So model selection. Okay, model selection. I need to importing here the train test and split. Train test and split. Okay. Now I'm simply going to pass it here. Train test split. Train test split. I'm going to passing here my X and the Y. So X comma Y, and I need to giving here my test size. So test size, let's giving here 0.2, and random state state, let's give it here 0. Okay, now I assign it to the same variables. Let's call X train and Y train like this way. Let's say X train. Okay, let's try to make it capital. थोड़ा अच्छा लगता है. Okay, X test and Y train and the Y test, Y train and Y test like this way. Well, fine. Now it's convert our data set into the train, test, and split. So now let's apply the first machine learning algorithm. Let's call KNN. Okay, for that, I'll also import it here. Let's say from sklearn dot neighbors, and I'm simply going to importing here the k-neighbors classifier. Okay, k-neighbors classifier, because this is a classification problem, right? So also I'm going to importing here the accuracy matrix. Let's say import sklearn dot matrices. So matrices. And I'm simply going to importing here the accuracy matrix. So the accuracy score, and I have in the confusion matrices, and I'm also importing here the classification report. Okay, classification report. Okay, that's fine. Now let's assign into one instance of the k-neighbor classifier and trying to using here the knn.fit. So knn.fit, and I'm simply going to passing here my X train and the Y train. So शायद X capital होगा. थोड़ा शिफ्ट प्रेस करके एक्स प्रेस करेगा ना, कैपिटल ऑटोमेटिक हो जाएगा. Okay, that's really fine. Now I am simply going to checking for the accuracy score. So let's say knn accuracy, and I'm simply going to using here the accuracy score, and inside that I'm going to passing here my Y test, and I'm going to using here the knn dot predict, and I'm simply going to using here the X test. Okay, fine. Now let's try to printing it out, our training accuracy and also testing accuracy. Let's try to print it out. So print करना चाहिए. Let's start using the f string. थोड़ा तो सीखिए f string कैसे यूज करते हैं. Accuracy of knn is like this way. Okay, and I can passing here inside the curly brackets. So curly brackets में क्या देना चाहिए हमको, accuracy इसको देना चाहिए, accuracy इसको राजा. Then I'm going to passing here my Y train. I'm passing here knn dot predict, and I'm going to using here my X train data. Okay, and I'm simply going to copy this out. Let's try to check it for the Y test and the X test. So here is it. Here you go. Fine. Now let's also checking for the confusion matrix. So simply going to copy this out for the testing data, right? So simply going to copy this out, and I'm going to using here the training accuracy, and I'm simply pass it here. So thoda gap is यहाँ पर. So this is nothing but my confusion matrix. So let's say confusion matrix of KNN is this is the classification report. So let's try to make it classification report. So ये होगा classification report, okay, of KNN is, and I need to using here the classification report. Okay, classification report. I am simply going to pass it the y test, and all the things are okay. Fine. Now you can see training accuracy is 0.78%, and okay, it's the testing accuracy, not training testing. Okay, and testing accuracy is 63%. Confusion matrix is, oh भाई इसको confusion matrix करना चाहिए ना. Okay, अब आ जाएगा confusion matrix. This one confusion matrix y text and x text में है. Okay, confusion matrix में मुझे गैप भी देना पड़ेगा, नहीं तो सेम लाइन पे नहीं आएगा. सो लेट्स से बैकस्लैश एन दे दो यहाँ पर, इसके बाद बैकस्लैश एन यहाँ पर भी दे दो, तब आ जाएगा. Okay, now it's going to see it's like look the confusion matrix, and this is my classification report. So I can also giving here on backslash n here. Okay, दे दो. So अच्छा लगा ना? Up okay. Now accuracy 64%, and you can see training accuracy is nothing but the 0.78%, and also this one. Okay, I need to okay. So थोड़ा इलेक्ट्रिसिटी चला गया, उसके बाद लेफ्ट में चार्ज भी नहीं था, so चार्ज भी लगा दिया. Now we can start. Okay, so we have the linear classifier and also the accuracy score, the confusion matrix score, and also the classification report, right, for the KNN. So now let's try to apply here another machine learning algorithm called the decision tree. Okay, let's take decision tree. Decision tree. Life में अच्छे decision नहीं ले पाए शायद इसलिए. Okay, decision tree. Okay. So now what I can do is simply going to import it from sklearn. So let's try to import it here. Let's check. Let's from sklearn dot tree. I'm going to importing here the decision tree classifier. Decision again. Decision tree classifier. Okay, this one. Now let's creating here an instance of that. That's a DTC equal to decision tree classifier. Shift chapter decision tree classifier, and I'm simply going to using to fit it out. That's a DTC dot fit, and I'm going to using here xtrain, and also the ytrain. Okay, fine. Now I'm simply going to copy this one. Okay, copy this one, and I'm just going to simply do some modification on my that. Let's try to do this out now. Decision is okay. Now let's make it DTC. Okay, and also convert them into the DTC, and also here this KNN to the, let's make it DTC. Copy करो, paste कर दो, और इसको भी DTC कर दो, कैपिटल में नहीं, DTC, and let's start using DTC for the decision tree classifier. So you got here 1% accuracy in our training data. Which one is those last, just like that is overfitting our training data, and testing accuracy is 0.97%, quite good, लेकिन overfit हो चुका है 1.0. So for that I need to also do the hyperparameter tuning. That's why hyperparameter tuning is coming in the scene. Okay, hyper हो जा parameter tuning. Okay, fine. So now inside the decision tree, it having some hyperparameter like criterion, the max diff, the splitter, the mean sample list, the mean sample split, max number of features inside the decision tree classifier. We need to choosing the best feature from that, and after that we need to also using the grid search tree, to taking the best features and try to predict it out so that our model is not going to go for the overfitting. Okay, let's say from sklearn dot model selections. So model selection. I'm going to importing here the grid search cb. Okay, I'm going to using the grid search cb. You can also using here the random search cb also. So let's say random grid search cb. Okay, cb. Okay, for model not mode, इसलिए auto selection नहीं दे रही है मुझे. Okay, so now let's try to using here the parameters. Let's see using here the grid parameter. So grid capital meter para. Okay, parameters. Okay, now I need to initialize and all the parameters here. So let's say last parameter is called the criterion. So criterion. So criterion, it having the two criterion, Gini and the entropy. So let's give it here Gini and the entropy. Okay, now it having the another one that's called the max number of depth दे दो. मैक्स नंबर डेप्थ कैसे दे? लेट्स से 3,5,7,10. इतना ज़्यादा डेप्थ भी नहीं होगा क्योंकि डेटा सेट इतना लॉन्ग नहीं है. So let's giving here the splitter. So splitter, and there are the two splitter are available. Let's call best splitter and the random splitter. So let's say best, then we have in the random splitter. Random. Okay, fine. Now what I can do, we simply going to also initialize here the min sample list. So let's say give min sample samples list, and we having the inside in list. So क्या चाहिए 1,2,3,5,7 देते हैं यहाँ पर. Okay, then we having the min sample of split, samples of split, and I'm going to using here the 1,2,3,5,7, and after that I'm going to using here the max number of features. So max features, features. Okay, features, and I'm going to using here the क्या feature है मुझे. So there are so many features that are available like auto or the squirt or the lock 2. So that's auto, then having the squirt, sqrt, or otherwise it having the log base 2 too. So that's my parameters. So I can simply using it inside my grid search cb. So I'm simply going to pass it here my grid search cb and try to pass it inside my grid search cb. Let's pass in the dtc that you already initialize it. Let's try to using the grid parameters. So let's grid parameter, then we having the fold. Let's say give here the 5-fold. And jobs nahi chahiye, -1 de do. Let's give me the verbose. Let's give it here 1. Okay, fine. Now let's assign it the variable. Let's say grid search, SCARC search. Let's say DTC. Okay. Now I am simply going to assign it, try to fit it out. So let's say grid search DTC.fit in my X train data and the Y train data. Simple. Okay, it having some features. Model selection, sklearn model selection, sklearn dot model selection. अब हो गया. So it will take few times because it will fitting with the 1,200 candidate, total 6,000 feet, क्योंकि यहाँ पर डेटा सेट काफ़ी लंबा है इसलिए. ओके, थोड़ा एरर भी आ चुका है यहाँ पर. इनवैलिड पैरामीटर मैक्स फीचर्स. ओके, मैक्स फीचर शायद FEF फीचर्स. हो थोड़ा मिस्टेक हो जाता है यहाँ पर, इवन तो. Now inside the parameters I need to select the best parameter and also the best score. So let's say best parameter and best score. यहाँ पर से मुझे सर्च करना है and best score. Okay, so I can simply print it out. Let's call grid search DTC dot best parameters, and I'm simply going to printing the best score. So that's the best score. So inside the grid search DTC and dot best score score किधर गया? Score. Fine. Now this is nothing but my best parameter. So I can simply copy this out and I'm going to paste it here, and also I'm going to copy this out and I'm going to paste it here, just here. Now inside this classifier I just need to give in here all of the parameters that you actually get it. how I actually train it out. Okay, now I simply going to you can also see, you can pass it inside your parameter. Even though you can also pass it here, the estimator you can also give it here. Let's give you another technique. Let's say DTC equal to grid search DTC dot best parameter. You can also using here the best estimator like this, so that you don't need to actually creating here these things again and again. In the earlier tutorial, I see that I just creating here one an instance of the DTC, and when I get the features, I just simply going to pass it inside these parameters. So you can also using here the best estimate like this way and try to predict it. Okay, try to predict it. Now you can see you're getting here 0.98% accuracy into my training data set, and for the testing data set, I get here 97% accuracy. Look like the model is not getting the word fitted. So now after that, what I can do, we simply going to apply here another machine learning algorithm, which we call the random forest algorithm. So we have in all of the max number of div, the max number of features columns. So I can simply going to pass it inside my random forest also, because random forest means all it's making so many decision tree, having so many decision tree. So now what I can do, I simply going to creating here one random forest classifier and try to predict it out, right? Well, so now let's try to using here the random forest classifier. So random forest classifier. Okay. So now I'm going to import it from sklearn. Let's get sklearn dot ensemble, and I'm going to importing here the random forest classifier. Import the random forest classifier and try to creating here one instance of the, let's call ren ren classifier CLF. Okay, now I'm going to using here the random forest classifier, and try to giving here all of the value that we get inside the DTC also, because DTC is also one kind of the random forest, using some decision tree classifier to creating here one random forest. Okay, so let's give here the criterion. Okay, criterion, let's giving here क्या यहाँ पर गिनी आया है. Okay, let's start giving here the Guinea. Okay, and I don't know Guinea is available here or not. Let's giving here the max number of depth, EPTS depth, and another giving here depth. Let's giving here the 10, and let's giving here the max number of features. Let's giving here the features escort, SQRT, and then we have the mean sample lips equal to 1. Okay, mean sample lips, the mean sample split. So I can copy this out from here. Okay, and simply going to paste it here and try to remove it. Mean sample lips, let's try to make it mean sample split, and we have the, okay, and it also mean sample lips equal to 1 and mean sample split, okay, equal to 7. I don't have the splitter in here, just to give you the number of estimator. Okay, number of estimators. Okay, so let's give it the 400. Okay, now let's start using here the random forest. Let's say rand CLF and try to fit it out. Let's say fit my X train and also the Y train data. Okay, that's fine. Okay, embedded index, max features, max number of lips. Okay, I need to using here equal, and also using the equal here. Okay. Okay, it's actually creating here the random forest classifier. Now we can simply go into printing the same things that we see earlier in these cases. Going to copy this out and try to convert this to be ran CLF accuracy and try to using it here. Let's say ran classifier ran CLF and try to make it at rand. Let's say random forest. Okay, random forest. I'm simply going to paste it paste it, and try to using this random classifier and try to paste it here. Just change it. Okay, it's not a big text. Okay, and another two using the shift enter. Now you can see I got here accuracy is 0.99 and testing accuracy is 0.97, which one is far better than decision tree. Okay, decision tree got here 0.97, and which one is also good, but in the training one, in the training accuracy got here 98% accuracy inside my decision tree, but inside the random forest classifier I got here 99 percent accuracy. So which one is also good? So now let's try to using here another algorithm called the XGBoost. So what I'm going to do, I'm simply going to using here the XGBoost. So I'm simply going to creating here one instance of the XGBoost boost classifier. So I need for that I also import it. So let's say from sklearn, not sklearn, it is available, it's not available inside sklearn, it's having the another extra features, I mean another extra variable, so not variable, actual library. So I'm going to importing here the XGBoost or XGB classifier. I'm simply going to creating here the XGB classifier, classifier, and I'm simply going to passing here my objective. Let's giving here the objective. So objective, let's try binary or the logistic, binary or logistic, and simply I'm going to using here my learning rate. It having some extra feature called the learning rate, and I'm going to make it 0.001, and I'm going to give it the max number of depth. So let's give here 10 instance of that is the earlier. Now let's give here the number of estimators. Let's give here 100. Okay, now you can simply going to print it out, not printing, feed it out. Okay, so call xgb equal to this one. Let's call xgb dot fit, and I'm going to passing here my x train and also the y train. Okay, that's fine. Now we have our XGBoost classifier. Now we can simply going to copy this out, and I'm going to paste it here and try to change something here. Let's say this is called XGBoost XGB. Okay, let's make it XGB now, XGB, and try to just replace this XGB, XGB, and XGB, and try to make it out random classifier to XGB. Okay, XGB, and try to make it out also XGB copy and थोड़ा paste split करता हूँ मैंने, थोड़ा split कर दिया, split click करो. Now you can see here we have 98% accuracy on the training data, and testing data accuracy is 97%. It's quite good. So now let's try to using here another algorithm called logistic regressions, just feeding that data to the model. So let's say from sklearn dot linear model, I'm going to import in here the logistic regressions. So logistic regressions. Okay, and I'm simply going to using here an instance of them. Let's say logistic regressions, and I'm going to using here lr dot fit to the x train and the x test. Okay, x train and the y train. Simple. Now I'm just simply going to copy this out. थोड़ा मैं split कर रहा हूँ क्योंकि it's nothing but the not a big deal to do that. So let's say lr, and this is called, let's say lr, and let's make it lr. Okay, so lr, and just copy this out and simply going to paste it here. This is nothing but for logistic regressions. Simple. Okay, simple. So you got here 89% accuracy in the training data, and testing data you got here 91% accuracy. Which one is not so good? Okay, so what I can do is simply going to using here the SVM. In the SVM, it having the hyperparameters, so you can also do the hyperparameter tuning inside the SVM. So what I can do, I'm simply going to import it. Let's say from sklearn dot SVM, and I'm going to importing here the SBC support vector classifier. Then from sklearn, sklearn dot model selection, I'm going to importing here the grid source CV. I think I already imported here. So let's creating one instance of the SVM. So let's call SBC, and I'm passing here my probability. Let's give here probability should be true. And now I'm going to give here my parameters. So for the network initialize here the parameters, parameter meters, and inside the list it's having two parameters, gamma and c. So let's give here the gamma, so 0 0.001, 0 0.001, 0 0.01, and having 0 0.1. Okay, now it having the another value, let's call c. Now let's say 0 0.01, 0 0.05, 0 0.5, 0 0.1, 1, 10, 15, 20, just some random values. And I'm simply going to searching the best parameter from here. Let's say grid search, and I'm going to using here the grid search CB. So grid search CB, I'm simply going to using here the SVM and try to giving here the parameters, this parameter, and try to using here the grid search CB. So grid search dot fit with the model, and try to checking for the X train and also the Y train. Okay, that's it. Okay, so now let's check this out. So it will fitting with the parameters, so it will give me some best parameters. So for that I'm simply going to printing it out. Let's say printing the grid search dot best parameters, and also I'm going to printing here the grid search dot best score. So this is my best scores. So best parameter is nothing but c, and the gamma is nothing but 0 0.01. So what I can do, I simply going to pass it inside my SBC. So I'm going to copy this out. Okay, not copy, just copy this out, and I'm going to using here the gamma equal to 0 0.001, and I have the value of the c. Let's giving here the c equal to 15. Okay, now I'm trying to fit it out in my model. So let's bm dot fit with my training data. So let's x train and the y train. Okay, invalid syntax, I need to giving here equal. Okay, this is my SBC now, so I'm going to copy this out, the same thing, and I'm going to pass it here. And let's say training accuracy of SBC, SBC, the SBC, and also the SBC. Let's make it is our SBC, and I'm going to make it called SBM. Okay, so SBM, let's make it also SBM. Okay, I'm going to copy this out and try to paste it here. Okay, so now you can see you got here 73% accuracy on the testing data, quite low. And for the training accuracy, we having just a 98% accuracy. So now let's apply one last machine learning algorithm called the gradient boosting. Okay, that's the last one. Okay. Okay, so it's called the gradient boosting. Okay, BOOSTIM boosting. Okay, so from sklearn dot ensemble, and I'm going to importing here the gradient boosting classifier, and I'm going to creating here an instance of that. Let's have GBC gradient boosting classifier, and after that I need to use here the parameters. So parameters. Okay, parameters. So what I can do is simply going to giving here parameter called the loss, and it having the another parameter called learning rate. So it having another parameter called the number of estimators. So number of estimators. Okay, let's giving here the first one. So let's 100, 150. We can give here 180, 200. Okay, that's it. Now give here the learning rate. So you can give here 0 0.001, 0.1, 1, or even though 10. Now giving the loss. So there are two laws are available inside the gradient boosting, which is called the deviance, and another one is called the exponential. Let's giving here the deviance, and also let's creating here exponential, exponential. Okay, exponential. Okay, fine. Now let's keeping in the comma. Now I am simply going to creating here one method, not variable, called the grid search gbc, and I'm going to using the grid search cb, and inside them passing here the gbc the parameters. So parameters is a capital number, capital format parameters, and I'm going to be in the fold. So let's say cb equal to 5, cb equal to 5. Then I have to giving here the and number of jobs. So number of jobs equal to -1. So but both same things, right? Equal to 0. Okay, let's giving here 1 now. And now let's giving here the grid search gbc dot fit with the x train and the y train. Simple. Now it is feeding to the data. Okay, so after that what I can do, I am simply going to creating here the BAST parameters and also the BAST score, and try to creating the gradient boosting, right? So I'm going to copy this out. So यहाँ पर paste करना है. So let's try to print it out. The gbc grid search gbc dot BAST parameters, and I'm going to also printing it here. So printing it here. So learning rate we got here 0.1, loss is exponential, number is estimated 100. This is my BAST parameter. Let's try to also searching for the BAST scores. So grid search gbc dot BAST score. Okay, so BAST score 97.5, mostly similar, mostly similar. So let's giving the learning rate. Let's say learning rate is 0.1, and the loss is equal to exponential. And now let's give here the number of estimators equal to 100. Okay, fine. Now let's try to fit it out. gbc dot fit, and I'm simply going to using here my x train and the y train. Okay, so this is my gradient boosting. So now what I can do, I'm simply going to copy this out again. Okay, and try to checking for the casting accuracy. So let's make it gbc copy gbc. Let's make it our gbc gradient boosting classifier. Okay, यहाँ पर तो गड़बड़ हो चुका है. Off. Okay, fine. Now let's start using it here. gbc fine. Now you can see here training accuracy is 1. तो ओवरफिट हो चुका है, और टेस्टिंग एक्यूरेसी इज नथिंग बट 0.97. ओवरफिट तो हो चुका है, so not a problem actually. So we can also giving here the kind of learning rates. So let's start using here one. Let's check this out. My one. Okay, simple one. Loss, let's using here the deviance, and number of sprint, let's using the 150, and checking this out. So loss parameter gradient boosting must be a string, log, or exponential. Okay, got deviance instance, so I need to using here the loss, log loss. That's why maybe this error. Let's try to import it here, log loss. Now let's check this out, that he got here the correct accuracy. I think the deviance is not available inside this gradient boosting, so that's why it just give me the exponential, and our model is getting overfitted. Okay, overfit तो हो चुका है. Now let's try to check this. deviance नहीं है यहाँ पर. Okay, log loss है. Okay, learning rate, let's using here 0.1. Okay, now let's tracking for that. Again. If I using here the 1, again. Okay, if I using here the 1, okay, and you can see here just warning for that. Let's using 0.1 now. Okay, it's verifying the data, the gradient boosting. You can using it out. Now what I can do is simply going to do the model comparisons. So model comparison. Okay, so I'm simply going to creating one data frame for the models list. So models. So let's creating here pd dot data frame, and inside that I'm going to pass that all the value in a models with the score. So let's get model and with having the score. Okay, a score. Okay, fine. So models, let's try to put it inside one list. So first, let's say using the logistic regressions. So let's say logistic regression. Then we have the KNN. Then we have the SBM. Then we have the decision tree classifier. So also called the DT. Then we have the random forest classifier, random forest classifier, fire. Okay. Then what we have? We having the XGBoost, so called XGBoost. Then we have the gradient boosting. Okay, fine. Now let's assign into also the scores, so we can passing here the scores of all of the things. So let's giving the LR accuracy. Then we have in the KNN accuracy. Then we have the SBM accuracy. Then we have the DTC accuracy. Then we have the RAN classifier accuracy. Then we have the XGB accuracy. Then GBC accuracy. Fine. Now inside that, I'm going to sort all the value based on my scores. So let's say sort value by score. Okay, a score. That's it. Now I'm going to make it ascending. Again उसके आगे ascending आता है नहीं, ascending नहीं आ रही, ascending equal to, let's make it false. Okay, model is not defined. Models नहीं, models by models है. Okay, decision tree give me the highest accuracy, 97.5%. I see most of the things are in the same accuracy format. Okay, so what I can do is simply going to import the pkl, and I'm going to checking my best one is nothing but my decision tree classifier. So tale de do decision tree. So using here the DTC, and now I'm going to using the pkl.dump, and I'm going to passing here my model, and after that I'm going to using here the open method and try to make my classifier name. Let's call kidney kidney.pkl in a mode wb. Okay, now inside my that folder you can see here kidney.pkl file is created. That's really fine. So now what we're going to do is simply going to creating here the RC curve and also the model performance. So video काफी लंबा हो चुका है, so it's better I can just typing it out, and after that I'll pause the video and discuss about this thing here, right? So well, I type it out, and you can see here we have in the ROC curve or the kidney disease predictions, and this is for the logistic regressions, and this is for the DT 0.94, and Axiboost having the ROC curve area is nothing but 0.9796, and also for the GBDT. So so this is for the ROC curve. You can add it inside your disease paper, and this is nothing but for the model comparisons. So if I check this out in the decision tree, it having the higher accuracy. Okay, 97%. All the things are same actually for that, getting the highest accuracy. But based on the ROC curve, we can see that in our the Axiboost, it having the ROC area is nothing but 0.96. So hopefully it will be better, the best model. Okay, you can also import it like this way from pkl format, so you can add it here on your peppers, and this is the model comparisons in a performance evaluation, that which model is actually working fine. In the KNIC, just less number of accuracy. Uh, it's just having the 63% accuracy on the testing data. So that's it for today now. Hope you enjoy this tutorial, and make sure to subscribe to the channels, and don't forget to hit the bell icon, and I'll be back with the other tutorials. So till then, take care and bye bye.